Hello and welcome to lesson 2 of week 6. My name is Mildred. In this lesson, we are going to go further to create our database and the tables in the database for the hepatitis B infected pregnant women form that we looked at in the last lesson. In the last lesson, we have created a plan where we are going to have 5 tables that are grouped under a registration category, and then we have 3 other tables grouped under the pregnancy category, and we want to link these tables to keep the integrity of the data in the table, and we're going to do all of that in this lesson. So the first thing we want to do is create a database, then create a registration table, an address table, an ethnicity table, an insurance table, a date of birth table, a pregnancy registration, laboratory results, and a clinic information table. And so let's start. The first thing we want to do is to create a database, which will say create database if not exist, and the database we want to create is called Hep B model. We want to set the character set and the collation, so I'll say character set, and the character set I want to use is UTF-8 MB4. We want to set the collation, so collate will now be UTF-8 MB4 Unicode TI. And then when we create this, we want to use the database we created. So what I'm doing is creating a whole script that once we run, it creates the database, it selects the database, it creates all of the tables in the database. The first table we want to create is the registration table, and let's go back to look at that. The registration table will have columns for ID, created by, unique ID, first name, last name, middle name, country of birth, family language, and then the update information. So let's do that. So create table if not exists, and want the table name to be registration, and then in a pair of parentheses we specify the column definition, but outside of the parentheses, after the close parentheses, we want to specify the engine we are using, which is the InnoDB, and we can also specify the character set and collation for the table columns. So we can say default here should be, let's say we want the default char set here to be equal to, let's say UTF-8 MB4. So we say collate here to be equal to UTF-8 Unicode TI. So I'll use MB4 here, and then we put a semicolon. So it is between the start and end parentheses that we define all of the columns. We want to have a primary key, and that is going to be like the ID for each column, and we want this to auto increment. We want this to be an integer. We want it to auto increment, and what auto increment does is that you don't need to insert values into this column. It just automatically increments from the last insert. So if the first insert is going to be 1, the next 2, 3, 4. You might want to specify the start for the auto increment. I'll show you how to do that later on, but we'll do the data type and the constraints we want to specify. So the table definition consists of creating the table, giving the table a name, listing the names of the columns that we want, and then defining the constraints and the data type for the column. So to make this fast, I'll copy all of this and I'll paste it here. So we want this to be an integer, we want it to auto increment, and we want it to be a primary key. A primary key we can use to uniquely identify a row in a table. So we can make an ID a primary key, or we can decide that we want to use the unique ID as the primary key to uniquely identify this row. I prefer to keep it with the ID, and I would just want the unique ID to be unique and not be a primary key for this. Created at is going to be a timestamp because we want it to be automatically stamped when the record is entered. And so we'll put the data type as timestamp. Now ignore my use of upper and lower case mixed together. I just want to illustrate that this is case insensitive, but by convention we always specify all of SQL keywords in uppercase, and then the definition, table name, column names in lowercase letters. So we want the data type of the created at to be a timestamp. We want to specify a not null constraint. so that there'll always be a value here, and we might put the default value to be null like this. So we can separate them by commas. The created by, we don't know what the name of the person is in advance, so we can use varchar and we can specify 255. We can also say this is not null because we always want to know who inserted the value in this. So I'll just change this for the sake of neatness, and I'll change this to primary key. We want the unique ID to also be varchar because we don't know in advance what is going to be the criteria for generating unique IDs. And so I'm going to put this to be of size 20. I also want this to be not null. Every person registered must have a unique ID, and I want this to be unique. No two rows must have the same unique ID. The first name we don't know in advance, so we use variable character, and let's give it 200. The last name and the middle name, I'll copy the same thing and I'll put that here. The country of birth we don't know in advance. The primary language. Updated at will have the same timestamp, but it's not going to be a not null column because we only want when an update happens. So here is going to be varchar, and let's use 255, and then we are done with this table. We can copy this and make things faster and create a next table, which is the address table. So we change this to address. Now the address table, we only need the address, city, state, zip code and phone number. So I'm going to copy that and I'm going to paste it here. And for the address, we want it to be, let's say, text because we don't know how long it will be. We want the city to be, let's say, varchar, and we'll make it 200. The state's the same. The zip code, let's say we want it to be 10. Now we don't know what the zip code will be based on the country. Some countries have alphanumeric zip code, some just have numeric zip code. So telephone number also will allow the telephone number to be varchar, and we're going to put it to be of length 20. We're done with this, so we're going to make this comma. We want to create the next table, which is going to be the ethnicity table, and all we need from here is just the race. And so we're going to do this here, and I'm going to delete all of this, and I'm going to change this to race, and let's say we want this to be varchar, and let's say we want this to be 100. So once you get a requirement and you look at the form field, or you are designing for a particular location, you can know in advance how many characters, what will be the data type, what will be the size. But now we're randomly filling in things, and this is not going to be the way you would design, except if you are not given a specification and you are making things up on the fly like we're doing now. Now we're done with the address. I want to look at what next. So this is ethnicity, sorry. So always remember, when we copy and paste, let's remember to change things. So we're done with the ethnicity, and the next table we want to create is the insurance, and all we need is the type of insurance. So I'll copy that. I will change this to insurance, and the type of insurance, I'll leave this as varchar 100. The next table I want to create is the date of birth table, and I'll change this to birth date. And for this table, we need the date of birth only. So I'm going to change this to date of birth, and this is going to be of type date. So we are done with the tables under the registration categories. Let's look at registering the pregnancy. We want to have a pregnancy registration table that gives every pregnancy a unique pregnancy ID. And so I'm going to still use that and paste here, and I'll change this to pregnancy registration. This pregnancy registration will have a pregnancy ID, which is also unique. I'll change this to pregnancy ID, and I want this to be unique. It will have estimated date of delivery, and estimated date of delivery is going to be of type, let's say, date, and then we're done. The next table we have here is the laboratory result table, and so I'm going to copy that because now we need a pregnancy ID for the lab results and for the clinic information, because they are all about the pregnancy. So we're going to have laboratory results, and here we want to have, I'll just copy it to make it easier, copy all of this and result upload. So this can be an enum of yes or no, because it's asking if the client knows of the status. So we'll put yes, no, and let's put the third option unknown. And maybe we want the default to be unknown. So you can specify default values. Sometimes you get error messages for having a not column without a default value. So you can specify default. I feel that default not null is just redundant sometimes, because if you don't want a value to be null and then you're specifying a default, which means that you still allow null but you insert something that you want in there, it's except in the event where you just want to specify a particular value that you use for data analysis to know that a value was not provided, this is what the default is. But other than that, I don't see any reason you should enforce a default on columns. So we have the next column, and this will also be an enum. Let's say an enum of positive, negative, and unknown. So let's say positive, negative. It's better you leave them in lowercase. The first ones are in uppercase. I'm changing that. So let's make it neat. Always make your work neat. And the default here is unknown, and this is unknown. So I'm going to do this also. This exists twice. I'll copy this and I'll paste it here. I'll do the same thing for this. I'll do the same thing for this. Now for result upload, let me tell you, I will not insert an uploaded file in a database table. Some people do that and they use blob type, but I will not. I will want to have a reference, a file reference to where on the server or where in the file system I can get that result. So I will use voucher 200. This might be too much, but all we want to do now is the reference, the path to the document. We are done with the laboratory result. Now for the clinic information. I'll copy this and I'll paste it, and I'll name this clinic information. For the clinic information, let's look at what we need. We need all of this information. I'll copy that and we'll make it faster. The file number in surveillance, we don't know what it will be in advance. Let's just use voucher, and we don't know the size. I'll just use 20. The OB provider name, let's say this is going to be voucher 255 or 200. So I'm going to copy this, make it faster. So when you copy and paste, just make sure you read it carefully, and we're not copying and pasting errors. Expected delivery facility, we don't know in advance, so use voucher reporting facility, and then the address of the facility. Let's use text for address in case if the given description. The city, we use voucher. The state, we use voucher. The zip code, we use voucher. Let's make this 20. Contact person at the facility, we use this. Contact person's number, we use this. You can let it be null. And then the date completed, we want it to be of time date. So we have created all of the column definitions for the table, but something is wrong with these definitions. Now all of these tables are related and they're supposed to contain information across board for one person. If I register somebody, the person has to have a record in the address table, the person has to have a record in the ethnicity table, the person has to have a record in the insurance table, in the birth date table, in the pregnancy registration table, in the laboratory result table, in the clinic information table. Once a person is registered, we want the system to automatically create files for them in all of these tables. But what if we delete someone from the registration table? Then the integrity of the whole table is violated. The records are not correct across tables. We want to keep integrity of tables, and this is where we use a concept called foreign keys. We use the foreign keys to make sure that we do not perform actions that would destroy the links between tables. The registration table has a unique ID column. This unique ID is the identity of the person registered. We want to make this the parent, and we want to make it a foreign key across the rest of the tables. We specify foreign keys like this. You can decide not to name your foreign key and just go ahead to write foreign key, and you want to specify which column here is the foreign key. The foreign key here we have is the unique ID. So I can put it in parentheses, foreign key, unique ID. And the reference, we want to specify what the parents table is. So say references, and the reference is going to be the name of the parents table, which is registration, and the column of that table, which is unique ID. There are rules for foreign keys about what the data type of both the parent and the child should be. I want you to read about that. But this is how we specify foreign keys when we do not want to name the column. Another way we can do this is to name our foreign keys, which even makes it easier for us when we are doing other operations, or when we want to drop the foreign key or alter it. We can do something like constraint and give it a name. So this is not spelled correctly, A before I, and give it a name. So let's say this foreign key is, let's put it FK address, and then so we've named our foreign key FK address, and then we specify the definition. We might want to also specify what happens when the parent table is updated. So we can say something like on update cascade, which means that once the parent table is updated, updates this table. So if the unique ID column is updated in the registration table, it will be updated in the address table. If you want it also deleted, so that when you delete anything from the registration, it deletes everything down, you can also add on delete cascade. And we are done defining this table. We are done with this. So we can copy this and use it on the rest of the tables, since we want the unique ID to be linked on all tables. We'll change the name here to be foreign key. This is ethnicity. We'll do that here. Make sure that you put a comma on the last column definition before this. It is the last thing before the closing parenthesis for the table definition that shouldn't have a comma. So we'll change this to foreign key insurance. We'll paste down at the date of birth, and we'll change this to foreign key TOB, and then we will go to the pregnancy registration and we'll do the same thing here, foreign key reg, and then we'll come down here to the laboratory results and we'll do that here, foreign key lab results, and then we'll do that for the clinic information, foreign key clinic. Now we have done this all round, but let me tell you, professionally I will not specify unique IDs in the laboratory results and on the clinic information table, because I already have the unique ID linked to the pregnancy ID that I specified in the pregnancy registration. But to make your life easy, we specify it for now, and as we go advance, you understand what I'm talking about. The laboratory results and the clinic information are linked to the pregnancy registration table. So we want to have another foreign key that links the pregnancy with the lab results and the clinic information. So once that pregnancy is deleted, those records are deleted from lab results and from clinic information. When it's updated, we want it to cascade down. So if there's a change in pregnancy ID, we want to know that this lab result is for that same pregnancy and keep the integrity. How do we do that? We put a comma here and create another foreign key, and this time we'll say foreign key lab res pregnancy, so that we'll know it has a different name. Now the foreign key here now is pregnancy ID, and the parent table is pregnancy registration, and the column is pregnancy ID column. We'll do that. Let's copy this. We'll do that for the clinic information. So put a comma and add this here, and I'm going to change this to clinic preg. So we have all of this defined. We have our integrity constraint put together. Read further about auto commits, about primary key, about foreign keys. We specified our constraint on some of the columns. You can actually not put a primary key constraint here and come down here to name it and put primary key and name the column that you want, something like this, primary key, and then you put the name of the column that is going to be a primary key. Now there are different ways to do this. You're going to see different ways. You can also name it and say constraint. Let's say constraint, and the constraint name we want to give this is, let's say primary key, let's say PK clinic, like this, and then we'll define the primary key. When you name your primary key, you can specify more than one column here. The whole rule is that we can only have one primary key per table, but several columns can be unique. So you can ensure uniqueness by specifying the unique constraints. But because we can only have one primary key, we can have one primary key named PK Clinic that is made up of more than one column, let's say ID and unique ID. So we're not going to get into this complexity. It's not that complex, but I just want to show you that there are different ways of doing the same thing. Choose what works for you, choose what fits your scenario, and what will make the table easy to maintain. So we are done with all of this, and the next thing we want to do now is to run this file to see if all is well for this to be created. So I'll run this, and something is not right with the registration table. The storage engine we specified was not correctly spelled, so these are the kind of errors we'll have in ODB. And I'm sure that because I copied and pasted, I have the same error all down. So we're going to do that. We can just do find and replace, but let me just replace them manually. So let me go up there and specify InnoDB. So look at how one error halted our creation, typographical error. So this is the danger of copy and paste, where we copy errors all through. So I'm glad that this happened so that we can see how careful we'll be. And because we use if not exists, we can still run this file and it's not going to generate errors that this already exists, because the database creation already succeeded. And if we did not have if not exist here, we're going to have an error saying that cannot create database because it already exists. But now it's going to ignore creation and going to create the tables. And so we have it created completely to the end. And because we said use this, when we refresh this, we'll see it there and already selected. If we'll expand the tables, we'll see all the tables created. If we'll expand each of the tables, we'll see the columns. And if we want to see the foreign key constraints that we defined, we can expand foreign key and we'll see the foreign key name. And we can look down here to see the targets and all of the definition for the foreign key. This is where we end this lesson. Thank you and see you in the next lesson.